For lesson 4-2, we're going to learn about step functions. And step functions are piecewise functions that you learned about in the last lesson. But the function part of a step function is a little bit different because it is, like it says right here, a constant value. It's just a constant value. Well, let me remind you what that looks like. So if I ask you to graph y equals 2, okay, let's go see if we can go to a Desmos calculator. If I ask you to graph y equals 2, hopefully you recognize that y equals 2 is just a horizontal line, because what it has is just, it's made up of a whole bunch of points that have the y value of 2. There's the point 0.02, there's the point 1.42, there's the point 2.2, there's the point 5.2, there's the point -5.2. It's just a whole, every point on the y equals 2 line has a value of 2. So it's just a straight line. So if I were to graph y equals -2, it would just be a horizontal line that is at -2. All of the y values are -2. There's there's +1, the point 1, -2. There's the point 2, -2. What do all of the points on this line have in common? They all have a y value of -2. That's why the equation is y equals -2. So what this is telling me right here, that the equation that I have over here needs to be restricted, and there's a couple of different ways we can do it. We can restrict it right here, but that's restricting, I don't want to do it that way. I want to put the restriction in by putting in the, the braces and little curly braces. And then we say, what this is telling us right here, that x is less than -3. So make sure you understand what that's telling me. It looks like it went away. Oh, I put a minus. I meant to do less than. There we go. Okay, now that makes more sense. So what this is saying is here that we still want that y equals -2 line, but we won't only want it for values when x is less than -3. So, or x is less than, sorry, -3. So the first point that we have here is, now notice that when I go to -3, it says it's undefined. And do you see that it puts an open circle right there? And it puts an open circle because we don't have a bar underneath here. So when you plug in -3, it's saying we don't have a value because we can't include -3 in that domain. So, but then as soon as we get past that -3, all of these points that have, that are less than -3, they have the y value of -2. That's what it looks like. So if we were to graph that over here, then basically what we're saying here is that we would graph the y equals -2 line, but we would only go up as far as the -3 on the x-axis. And we put an open circle right there. So it's just got this little straight line and then the open circle. Now for this next part, if we graph the y equals 1 line, remember that's what each one of these are. This is 3 different functions, y equals -2, this is y equals 1, and this is y equals 3. Those are 3 separate functions. And then they're dividing the domain up for each one of these parts. So we're going to have the line right here at -2 as long as our x value is -3. Once our x value becomes -3 and between 2, so between -3 and +2, the y value is going to be 1. Okay, so it's going to pick up right here. It's going to be filled in. and then it's going to be 1. The y value is going to be 1 all the way until we get over here to the 2. It's got an open circle because we're not including the 2. And then the part of the function, which is y equals 3, is going to be for the x values that are bigger than 2. So once I get on this side of 2, my y values are now at 3, and it's going to be a filled in circle because the bar is underneath there, and it's going to go this way forever. So this way is going that way forever. So it's got 3 different pieces. Because each one of these are constants, and they're called constants. Why are they called constants? Because there's not an x beside them. There's not a variable with them. They're coefficients if they're in front of an x. If they're not in front of an x, they're called constants. And when you graph a constant, it's just a horizontal line. Why do we have these 3 different pieces? Because we've got 3 different values of our constants right here. We've divided our domain up into 3 sections. We've divided it up into numbers that are smaller than -3, numbers that are bigger than +2, and then the numbers that are between -3 and +2. And so that's what that says. Now you can type this in on Desmos like I was showing you. I would change one little thing on Desmos. No, actually, I'm not going to tell you that because I don't think that I can get all 3 of them on the same. I was going to tell you to go back and do f of x, but I can't do f of x for all 3 of them because I don't know what's going to happen if I do this. I'm just trying. F of x equals, what was the graph? 1. And that's only good if we are between -3 is less than or equal to x is less than 2. And then this one is f of x. I guess it will let me do. I didn't know it was going to let me graph 3 different f of x's. And then this one is 3 with the restriction that x is greater than or equal to 2. Okay, now let me make this bigger so that we can see more of it. So this is what the graph looks like. Desmos doesn't put arrows on the end of its functions, but as we move it along here, we see that the red just keeps going and going and going. Okay, and then the green goes from here to here. Now, one thing that it doesn't do by itself is that it does not put the open and closed circles. You can put the open and closed circles. We know at the end of the red one right here, the open circle should be at -3, at -3, comma, -2. All right, now right now it looks like it's a filled in dot, but if I hit the settings up here and I go to this, I can click this and click this. So now it's red, and I click this button right here, and now it's open. So I've got the open circle right there. For this one up here, because it's filled in, that should be a solid dot. So it should be a solid dot at -3, comma, +2. Nope, +1, sorry. -3, +1. And then I do want it solid, but I would like it to be green. So I'm going to go here and make it be green. And then on this side, because I don't include the 2, I want that to be an open circle. So I say at 2, 1, and then I want it to be green, and I want it to be an open circle. And then for this one, I want the circle to be solid, the end point to be solid because it's including the 2, and it's up at the point 2, 3. And this one's going to be purple. So 2, 3, make it purple, but make it filled in. So now my step function right here has all the proper endpoints. So while Desmos does a good bit of it for you, there are still some things that you have to add to it to be sure that you show your understanding. Now remember, the thing that we learned a while back called the vertical line test. The reason that you have to be very careful on step functions is that you do not want to have a place on your graph where a vertical line will pass through 2 points at the same time. Because if it does that, then it's no longer a function. And if it's not a function, then we can't put f of x in front of it. So what I'm saying right here is that I drew a vertical line, and you may be thinking, uh-oh, it passed through right here and right here. But remember, that's okay because this one's filled, so we're including the -3 for this point. We're including this -3. This -3 is included, but this -3 is not. Because it says right there, don't include that -3. Go all the way up to that point, but don't include it. So it may look like at first glance that it's going to pass through 2 points at the same time, but this one right here, this -3 is not being included. So we didn't fail the vertical line test. We passed it, and we passed it right here too because it's filled in right here and open right here. So that's why it's very important that you check your endpoints and make sure that you don't have 2 of them that are filled in right on top of each other, because if you do, then you no longer have a function. Okay, I'm going to go ahead and stop the video right here and continue on here in just a second.